we could throw an error if the user is not an admin. So it provides a controlled way of reading the email address rather than just accessing it directly with, say, user1.email. Okay. So, and the same thing is true for setting an email, because currently we can set email to any random value. So let's now add just a little bit of, say, validation logic to help to make sure that emails are actually set to email addresses, to valid email addresses. So what we can do in our set email method, we can say if there is an @ symbol in the new email, then we can set the email. Otherwise, we will not set it. And maybe we could also throw an error if there's no @ symbol, but let's just keep things simple for now. So let's actually have a look at what we've got here. So this is an invalid email address. It has no @ symbol. So let's see what happens. So you can see here, the email was not updated because it didn't contain an @ symbol. So you can see here, address it. You could also throw an error if there's no @ symbol, but let's just keep things simple for now. So let's actually have a look at what we've got here. So this is an invalid email address. It has no @ symbol. So let's see what happens. So you can see here, the email was not updated because it didn't contain an @ symbol. Whereas now if we provide an @ symbol and .com, you can see that the email is now a valid email and it is updated, it's set. Okay, so you can see the setter method is providing a controlled way of updating email addresses to ensure that the users of this class or the other parts of the program using this class cannot do anything stupid. Okay, so it really helps to improve, in this case, the integrity of the data throughout our program. And of course, this is not complete. We would also need to have other validation checks, but it's a nice simple example. So in summary, getters and setters allow us to access and modify data in a controlled way. So for another example, before we set a username, we could actually check that the username is not already taken in the database. Okay, and before setting a password, we could check that it's at least 8 characters long and contains both letters and numbers. And again, we could do this outside of the class, okay, by just accessing these fields directly without getters and setters. But then every time we set a password, we'd have to remember to validate it. Okay, and this leaves it possible for invalid passwords to be set. So it's much safer and also less code in the long run and much more maintainable to do the validation in one place within the class. However, so far we have looked at getters and setters, which is kind of the traditional Java style object-oriented programming approach, where we kind of set variables as protected or private and then provide getters and setters for each attribute. And this is a pretty verbose or long-winded way of doing something very simple. And it's often why you'll hear people complain that Java is a verbose programming language. And luckily, Python provides a much nicer, kind of cleaner and less bloated way of effectively doing the same thing using something known as Python properties. And that's what we're going to take a look at next. Properties are the recommended approach to controlling access to data in Python. So here we have an example, a very simple user class with an init method, which initializes an object's data attributes. So we give objects a username, an email, and a password. And here we are creating a user object, passing in some data. And you can see here that we are accessing a data attribute directly. Okay, so we're saying user1.email, and we are setting it to just some invalid value. And if we won't run the program, you can see we get no problem. This is all okay. So this is not good because we can freely, because any other classes or any other parts of our code base or our software effectively can freely read and modify emails. So anywhere within our program, anywhere else in our program that is using user objects can freely set emails to whatever value they want. So this is clearly not a good solution here. So the way that we can fix this, and the solution to this problem, is by creating getter and setter properties for the email attribute. Okay, so previously we looked at creating getter and setter methods, which is the kind of Java way of doing things, I guess you could say. Here we're going to have a look at the more Python way of doing things, which is using getter and setter properties. So first of all, I'm going to show you how you would go about this. So this is kind of the standard way of creating properties in Python. So first of all, what we do is we make the attribute private. So we can do that by prefixing with a single underscore. We then state the property decorator. So we say property, so at property. We then create a method with the same name as the attribute that we want to provide a property for. So we say def email because we're creating a getter property for email. Okay, and then we pass self so that we can actually access the current object's attributes. And then we just return self.email. Okay, so now what we can do is also create a setter property. So this is a getter property. So whenever we read email, we can just call user1.email. Okay, so I'm just going to comment this out for now, and we'll just focus for now on this getter property. Okay, so what we've done here is we can still access email by it looks like we're accessing the attribute directly, but actually we are accessing the email property, which is then returning the kind of protected email attribute. Okay, so now again, if we wanted to, for example, print something to the console every time an email is accessed, we can let's just keep things simple and say email accessed and run this. You can see that we are printing to the console email accessed before we print the email. Okay, so it's kind of very similar to using a creating a getter method, but it kind of makes access to email much more simpler because it looks like we're accessing it directly. And the advantage of this is if we actually remove the property and go back to, kind of what we were at initially, where we just have this self.email equals email. So this is a public attribute. You can see that any code that is using this, using these user objects doesn't have to change. If we were originally accessing the attribute directly, then all of a sudden we needed to provide some logic later on in our program to print email accessed. Then we can just add that in, and all of our classes in our program, which could be a lot of classes using these user objects, don't have to change. It still looks like we're accessing the email directly, even though we're actually now accessing a property. So that's the kind of big advantage of using a property. We can keep things simple initially. For example, if initially when we create our program, we don't require any logic at all when we get email addresses. We just get them and we read them, then this is fine. But then later on, maybe a few weeks down the line, the boss comes in and says that you need to now print something to the console. Every time we access an email, we can just add in this getter property, make the attribute private, but all of the code using user objects does not have to change. We still just say user1.email. Whereas with a getters and setters, if we made this protected, then provided a get email method, then all of the code using user objects would then have to call the get email getter method, rather than just keeping it the same as it was before. So that's kind of the huge advantage of properties. You don't have to worry about creating getters and setters initially when you create a class. You can just keep things very simple initially, and then later down the line, if we need to add some extra functionality, add some extra validation logic, then we can add properties in, and all of the code using these classes or objects doesn't need to change. So that's the big advantage of using properties over getter and setter methods. It's much less verbose, and it's kind of easier from the off, if you like, because if I was using getter and setter methods here, then I would have to be thinking somewhere down the line, it's very likely that we're going to need to add some logic to when we access or modify emails. So therefore, I'm going to have to make this protected right from the get-go, and then provide these getter and setter methods. Whereas with properties, I can just keep things simple, access things directly, and then down the line, if we need to provide some logic, we can just add the property in, and all of the code using the user object doesn't have to change. So that's a huge advantage of this method. So let's now take a look at how we can create setter properties. So we have a getter property, but let's now create a setter property so that we can actually set emails. And if we just uncomment this, you'll see that we have an error here. And this is because we cannot assign to attribute email for class user. And this is because we haven't actually created a setter property for this class. We've created a getter property, but we've provided no way of setting it. So if we actually leave our user class like this, it kind of basically means that we can read email, but we cannot update it. But we want the ability. We start with the attribute properties in Python. Don't worry too much about it for now. We create a method with the same name as the attribute, and here within the method, we have a parameter for the new email, okay, that we want to set email to. And let's just add some validation logic in here. So let's say if at in email. So this needs to be, let's see, new email. If at in the new is in the new email, then we can set self.email equal to the new email address. Okay, so let's actually run this to see if it works. So here we're trying to set email to this invalid email address. We print the email and you can see that it's not been changed because this doesn't have an @ symbol. Okay, so we now have a controlled way of getting and setting data for our user email attribute. So let's just break down this code and summarize what we've done so far. So you can see here, self.email, we've made this protected. So this is a protected instance attribute initialized to the value passed when we create the object. And the single underscore prefix means that it is protected, meaning that it should only be used within the class like we're doing here, and we don't use it outside of the class, which is what we are doing. So that's all good so far. And then we have this property decorator. So this @ symbol, @ sign with property. This is just the standard way in Python of creating a getter property. So what this property decorator does is it turns the following method, so this email method, into a getter property. And by making it a property, we can access this underscore email attribute using user.email, as we have done here, and well, as we've done here, because we're getting it here, we're setting it here. So for the getter property, we can see we can just access it by calling .email. Okay, so that's great. So so by naming this getter property email without the underscore, we are exposing a public email property while keeping this email attribute private. So you can see this is a public email property, public meaning we can access it outside of the class, and we keep the email attributes protected. And you can see here we just return, we are logging something to the console, then we return the value of the email attribute. Okay, we also then have a setter property. So the way we create these is we have a decorator starting with the name of the attribute that we want to create a setter for. Then we say .setter. Again, this is just the standard Python way of creating a set of properties. And this setter method is triggered whenever a new value is assigned to user.email, allowing us to add this validation logic or any other logic during the assignment to email. So whenever we call user.email equals some new value, this setter property method is called, giving us a chance to control the assignment. So far we've explored instance attributes in Python classes, and you now know that each instance or object of a class can have its own set of unique data. However, Python classes can also have static attributes, which are shared among all instances of the class. So in this section of the course, we're going to cover the differences between instance attributes and static attributes, when you should use each, and how the self keyword fits into the picture. So a static attribute, which is sometimes called a class attribute, is an attribute that belongs to the class itself and not to any specific instance of the class or any specific object created from the class. So this means that static attributes are shared by all instances or objects of the class. It also means that there is only one copy of a static attribute in memory, regardless of how many objects or instances you create from the class. And static attributes can be accessed directly through the class itself and also through the instances, although they are stored at the class level. So let's go through an example to make this easy to understand. So say that we wanted to keep track of the number of user objects that are created from the user class. So first of all, let's create a user class and also create a static attribute that counts all of the instances or objects that are created from this class. Okay, so let's clear everything out here. And I'm just going to create a user class. And here we're going to create a static attribute. So we're going to say user count. We're going to initialize this to 0 because initially there's going to be 0 user objects. We're then going to create our instance attributes, which, if you remember, are created in the init method. So we create the init method. We pass self first. We then pass a username and an email for the user. So each user object is going to have a unique email, username and email. But this user count attribute, which is static, remains on this user class, whereas these are instance attributes, which are going to be assigned to each individual object created from this user class. So we say self, or the current object, dot username is going to be equal to username, and the same for email. And these are our instance attributes. Every time we create a new user object, we want to increment the user count by 1. So the way we can do that is we can say user, so the class, and remember this is a static attribute which exists on the class, not on the objects created from the class. So we say user dot user count is going to be plus equals 1. So essentially we increment it by 1. Okay, so let's also provide a method for displaying the user. So we can just display the user's details, their username and their email in a kind of nicely formatted way. So we can say display user, and then we're just going to print a format string. So we'll say username is going to be equal to self.username, and we can say email is going to be self.email. Okay. So here we can see that the static class attribute is created in the class body. Okay, so within the class body itself. Okay, it's only indented once, effectively. Whereas the instance attributes are created inside of the init method. Okay, so that's the kind of difference of how we create static attributes and instance attributes in Python. So let's actually see if this all works correctly. So let's create a couple of users. So I'm just going to paste this in just to save a little bit of time. So we'll create 2 user objects, so user 1 and user 2. And since the static user count attribute is stored inside of the user class itself, we can access this directly from the class. So let's now access this directly from the class. So let's now count the number of users in the class. So we can say user.userCount. Okay, so we're counting the number of user objects created, because remember, every time we create a user object, we increment this static attribute by 1. So let's actually save this and run the script, and you can see we get 2 back. We have 2 user objects created, which is what we would expect. Now we can also access the user count from the 2 instances that we created here. Even though this static user count attribute is on the class, we can access it via the objects, but you should remember that it's still a shared static attribute. It's still accessing this one, static attributes stored in one place. It's not stored, uniquely on each object. Okay, it's just stored in one place on the class. So let's show you how you can do that. So we can print user1 dot user count, and we can also do the same thing with user2. Okay, so you can see this is actually accessing user on the class, user.userCount, but we can also access it from the instances created from the class. So let's just check if that works, and you can see it logs 2 each time we access user count. So the main things to remember here are that static attributes are created once at the class level and are shared between the class it resides in and the instance objects of that class. Whereas instance attributes are created every time we create a new instance, so here and here. And instance attributes are contained within that instance. So we can see that the instance attributes, self.username and self.email, are contained within each unique object. Okay, so these are kind of recreated and stored inside of each object that we create. Okay, so so this username attribute will be stored uniquely inside of this user1 object, and also for this user2 object, it will have its own username attribute assigned to whatever value we pass here. Okay, so that's the kind of difference between static attributes and instance attributes. So you may be thinking, when should you use static attributes compared with, say, instance attributes? So static attributes are useful for data that is common to all instances of a class. So let me give you some example scenarios where static attributes would make sense to use. So it makes sense to use static attributes for things like counters and totals, like, for example, tracking the total number of objects created, like this user count attribute is doing in our example here. So static attributes are also useful for shared constants, or values that are constant and applicable across all instances. For example, a default value or some sort of configuration setting. And they're also useful for class level configuration. So any configuration or setting that should be the same for all instances of a class, such as default parameters. So just to summarize, instance attributes are unique to each object and are accessed using, accessed within the class using self dot and then the attribute name. And they are ideal for storing object-specific data. So, unique data effectively. The username is unique, the email is unique. If it's a dog, then the breed needs to be unique to that particular object. Whereas static attributes are shared among all objects of a class and can be accessed with class name dot attribute name. And these are ideal for storing data that needs to be consistent across all instances. A static method in Python is a method that belongs to the class itself rather than to any instance of the class. So unlike instance methods, static methods do not take self as a parameter, meaning that they cannot access or modify instance-specific data. Instead, they are used for functionality relevant to the class but not tied to individual instances. And to define a static method, we use the static method decorator. So now let's go through a realistic but simple example to demonstrate the differences between static methods and instance methods. So let's now create an example to show the differences between static and instance methods. So we're going to create a class called bank. bank account. And this is going to have, first of all, a static attribute called min balance. Okay, and it's kind of a convention in Python to capitalize constants. So this is going to remain constant in the class, and it makes sense to have this as a static class attribute because it's going to be shared between all bank account instances. It really doesn't need, it's not going to change, and therefore it makes no sense to have it as an instance attribute. Next, what we're going to do is we're going to create some instance attributes. So we can do that in the init method. And we're going to have each bank account is going to have an owner and also a balance. And we're going to initialize the balance to 0. So in here we can say we create an instance attribute of owner, and we assign it to the owner passed in, and we can say self dot balance is going to be equal to balance. So here we're creating a protected instance attribute. Okay, and we're going to provide some methods that allow us to withdraw and deposit into the bank account in a controlled way. So next up, we're going to create our deposit method, which is going to be an instance method. Okay, and it's going to be an instance method because it needs access to an instance attribute, okay, which exists on the object. So it needs to be an instance attribute. So we're going to call this deposit, and we deposit an amount of money. And what we're going to do in here, we're going to add a little bit of logic. So we're going to say if amount is greater than 0, then we can increment the balance by the amount. So self dot balance plus equals amount. And let's just print a message to the console so that we can see what's going on. So we can say, let's see. So self dot owner, and then we'll say owner's new balance, and then we can just print the balance. Let's put a $sign here, self dot balance. Okay, and if the amount that we're trying to deposit is less than 0, we can say print deposit amount must be positive. Okay, and I'm going to create one more method now, and this is going to be a static method. Okay, so we do that. We can create static methods by using the static method decorator above the method that we want to be a static method. Okay, so now we can create our static method. We're going to call it is valid interest rate, and we're going to put in the we're going to pass the rate here, the interest rate. And what we can do is we can just return true or false if it's a valid interest rate. So let's keep things simple and say if the interest rate is greater than or equal to 0 and less than or equal to 5, then it will return true. Okay, so this is a static method that just exists on the class and not an instance method like this one. And I'm going to create one more method now, and this is going to be a static method. Okay, so we do that. We can create static methods by using the static method decorator above the method that we want to be a static method. Okay, so now we can create our static method. We're going to call it is valid interest rate, and we're going to put in the we're going to pass the rate here, the interest rate. And what we can do is we can just return true or false if it's a valid interest rate. So let's keep things simple and say if the interest rate is greater than or equal to 0 and less than or equal to 5, then it will return true. Okay, so this is a static method that just exists on the class and not an instance method like this one where we pass the self as a parameter, which will exist on each of the objects or instances that we create from bank account. So let's now have a look at how we would use this solution. So let's create a bank account and set it equal to bank account, and the owner can be Alice, and we will set the initial amount to 500. So let's actually deposit some money. So we can say account.deposit, and we can deposit $200. And let's actually log this to the console. So you can see whenever we deposit money, we get a nice message of the updated balance. And now let's actually use the static method that we created down here. So let's print. Now we can access static methods from the class itself because they exist on the class and not on each instance of the class. So we can say bank account dot is valid interest rate, and we can pass 3, and we can do the same thing again, and we can pass 10, and then we run this script, and you can see 3 is a valid interest rate because it falls between 0 and 5, and 10 is an invalid interest rate. So let's just recap what we have done here. So we have an instance method called deposit, and this method uses self. Uses self to access the balance attribute specific to each bank account instance, and calling deposit on account, so here, and passing in a value, increases the account.balance, allowing each instance to manage its own data independently. Whereas this static method called isValidInterestRate, this method does not interact with any specific account or instance. Instead, it performs a check on the rate parameter, which we pass in here, independent of any bank account object, making it suitable as a static method. And we call it directly on the class using bankaccount.isValidInterestRate and passing in an integer argument. So you might be thinking, where are static and instance methods stored? So both static and instance methods are stored in the class itself, not in each individual object that we create from the class. So this means that we have memory efficiency, as only one copy of each method exists in memory, no matter how many instances that we create. So just to clarify for when you should use static methods. So static methods are ideal for tasks related to the class's domain, but don't require any specific instance data. So for example, you can use static methods for like utility functions. So on this bank account class, we use a static method to check if an interest rate is valid. But you can also use static methods to help to process data or to format outputs that don't rely on any instance-specific data. Okay, so this method here doesn't rely on any specific object data, such as the owner of the account or the balance. It just takes in a rate and returns true or false. So it makes sense that this is a static method. It's kind of like a helper or a utility method. So using static methods can help to give a clear separation between behavior that requires instance-specific data and behavior that doesn't. And this approach also reinforces encapsulation, which is an important object-oriented program concept that we'll dive into shortly. So it reinforces encapsulation by keeping related functionality within the relevant class. So far we've discussed how we can control access to attributes by making them either public, protected, or private. But we can do the same thing with methods, again using one underscore for protected, which means to be used within the class or subclasses but not outside of the class, or two underscores for private, which means to be used within the class only. And again, we'll get more into using what subclasses are very shortly in the course. So let's take a look again at our bank account class. And let's say that we wanted to create a protected method, meaning that it should only be used in the class or its subclasses, to check if the amount being deposited is valid. So rather than having this here, we have a method that does this for us. So we can create a protected method with an underscore, and we can call this isValidAmount. And we pass self, we pass the amount, and we return the same thing that we have here. So we can say amount greater than 0. And we can now call self dot is valid amount. Okay, and then pass the amount. Okay, so this is a protected method. We can also create private methods. So let's, for example, create a method. We can also create is a protected method. We can also create private methods. So let's, for example, create a method that logs the transaction type and the amount being withdrawn or deposited. Currently, we only have a deposit method just to keep things simple. We didn't provide a withdraw method, but let's create this log transaction method. And this is going to take the self parameter and the transaction type and the amount. And then in here we can print. So let's see. So we can say logging the transaction type of amount. And we can say new balance is self dot balance. Okay. Now, rather than logging this message self dot balance. Okay. Now, rather than logging this message inside of the deposit method, we can just call this log transaction method. Okay, so we can say self dot log transaction, and then we can pass the transaction type. Which is a deposit, and we can pass the amount, which is amount. Okay, so this should work pretty much the same as before, but we now have a few extra methods. Okay, so amount. Okay, so this should work pretty much the same as before, but we now have a few extra methods. Okay, so we have a protected method here with a single underscore. So if we actually look at what would happen if we try to act, so we have a protected method here with a single underscore. So if we actually look at what would happen if we try to access this outside of the class. So if we have a scroll down, what did we call it again? So is valid amount. is valid amount, you can see that we can access this outside of the class, but we are not supposed to because it's got it's prefixed with an underscore, meaning that it should be used within the class only. Whereas the private method, which is called log transaction, so if we let's see, so let's say withdraw and 300. Now if we run the program, you can see that we get an error because this is a private method and we are not allowed to access it outside of the class. So you can see here we have the protected method, which is used internally to validate the deposit amount and is accessible by any subclasses if needed. And then we have the private method called log transaction with the double underscore, which is used to log transactions and is intended only for internal use within this bank account class. And this method should not be accessible or overridden in subclasses. Okay, and again, we'll get to that very shortly in the inheritance section of the course. Encapsulation is a fundamental principle of object-oriented programming that involves bundling the data, or the attributes or fields, and methods, or the behaviors that operate on the data into a single unit called a class. Encapsulation helps in hiding the internal implementation details of a class by only exposing the necessary functionalities to the outside world. So let's now create a simple example demonstrating encapsulation in Python. So first, let's create a bad example with no encapsulation. So we're going to create a class called a bad bank account. So this is our sort of bad example. And then we're going to refactor this to use encapsulation and solve the issues that we find with this bad example. So we're going to create an init method, and let's get rid of that. And we're going to pass in a balance, an initial balance, which we will set to a balance instance attribute. And let's now have a look at how any users of this class, so any other part of our program that uses this class, is a kind of client of this class. That's the kind of terminology that we use. So any other parts of our program, let's say we created a new file, some I don't know, account.py, and we imported this class, this new file would be a client for this bad bank account class. Okay, so any other parts of our code using this class effectively. So users of this class, or clients, now have free reign to assign balance to whatever value that they want. So first of all, let's create an account and pass in an initial balance, let's say 0. And we can now set balance to any value that we want, for example, a negative number. And this is not good because our program's logic, let's just say, should not allow the balances to be set to set to a negative number. Okay, but if we print the account.balance, we will see that it has been set without any errors being raised. Okay, so this is not ideal. So let's now create a better bank account class with encapsulation of the fields and internal logic. So let's just come down here and create a better example that uses encapsulation. So we have our init method, and in here we're going to set the balance equal to 0 initially, 0.0, so a float, and we're going to make balance a protected attribute, so we can't access it directly outside of the class. We are effectively encapsulating this balance attribute inside of the class, okay, making it inaccessible, or in Python at least it means we shouldn't access it outside of the class. Okay, so now what we can do is we can either provide a getter method or a getter property for getting this balance. And in Python, generally you want to be using properties because they are much, as we discussed earlier, much less verbose, and you can just create them as needed rather than getter methods where we have to create everything up front. So let's create a getter property for balance. So we say balance, def balance, self, and we're just going to return self dot balance. Okay, so there's our getter property. And let's now create methods for depositing money into the account. So what I'm actually going to do is I'm not going to create a setter property. Okay, what I'm going to do is I'm going to say that in order to modify the balance, we have to call either a deposit method or a withdraw method. So I'm going to create a deposit method here, and that takes an amount. And first of all, we're going to check if the amount is less than or equal to 0. So if we try to deposit 0 or less, which makes absolutely no sense, so we're going to raise a value error in Python with a message of deposit amount must be positive. Okay. Otherwise, if we pass this test, we can set the balance, so self.balance, and we can just plus on the amount. Okay, so we add the amount to the current balance. Okay, and now let's create a withdraw method. So we can say def withdraw, and we want to withdraw a certain amount. And again, these are instance methods because we are passing the self parameter, and we need to access instance data. So it makes sense that these are instance methods, or they need to be instance methods. Otherwise, we can't access the balance on each object. So in withdraw, what we can do, again, we can check if the amount being withdrawn is less than or equal to 0. Then we want to raise a value error, so let's just copy paste that, and we will say this time withdraw amount must be positive. And then we also need to check here if amount is the amount that we are trying to withdraw. If it's greater than the actual amount in the balance, then we need to also raise a value error, and we'll provide a message called insufficient funds. Okay, and if we pass all of the conditional statements, then we get to the end and we can just subtract the amount from the balance. So we can say minus equals the amount. Okay, so now let's go ahead and actually create an account from this bank account class. So we can say account is equal to bank account, and let's actually print the account balance. Okay, so because we have provided a property, a getter property for balance, we can just, access this balance property. It looks like we're accessing the balance attribute directly, but actually we're calling this method. And if we try to assign account.balance a value, so for example, -1, you can see we get an error. So we cannot assign to attribute balance for class bank account. And this is because we haven't actually provided a setter property. Okay, we're kind of forcing the user to use these two methods, okay, for depositing and withdrawing cash. Okay, so that's the way we've designed this class to work. So let's actually try to deposit some money. So we can say account deposit, and let's deposit $199, and let's print the account.balance, and then let's actually withdraw some money. So account.withdraw, and let's withdraw $1, and then print the balance. Okay, so let's run this program, and you can see, let's see, so let's just uncomment what we had previously. So let's uncomment all of this and run the program again. So we can see the initial balance is 0, which we are setting in the init method when we create a new account object, which we're doing here. We deposit $199, print the balance, and then we withdraw 1 and print the balance again, and all of this is working correctly. And if we try to do something stupid, such as withdraw an amount greater than we have in the account, so for example, account withdraw 100, we should get an error message because we are actually trying to withdraw more than we have an account, so we get this insufficient funds method. So now we have a nice controlled way of updating this balance field in the account. So let's just recap what we've got here. So notice in the bank account class, again, we've provided a getter property for this protected balance attribute, but no setter property. And this allows users of this class to read the balance using account.balance, but not set the balance directly with, for example, account.balance equals -1, which would still be bad. So to modify balance, bank account provides a simple public API, these two methods, deposit and withdraw. And this ensures the integrity of the balance attribute value and that our expected program logic can't be violated. So step by step, the bank account class encapsulates the account data, which is this balance attribute, and its related methods, deposit and withdraw, into a single unit of this bank account class. The data members, so balance, are marked as protected, encapsulating them within the class and preventing direct access from outside of the class. A getter property method called balance is used to provide controlled access to the protected balance data, and methods deposit and withdraw are used to manipulate balance, ensuring that operations are performed safely and according to the business rules of our program. So what we've demonstrated here is how to create an instance of the bank account class and interact with its properties and methods without needing to know the internal implementation details. So here we have a sort of user of this bank account class. So this can be, other developers maybe use this class, or other classes in our program, other files in our program or software using this bank account class. They can't directly access the balance field as it's marked as protected. So this data is encapsulated within the class, and the methods dictate the rules for how this data can be accessed and modified, ensuring that our program's rules can't be violated by users or consumers of the bank account class. For example, it's no longer possible to withdraw more money than is in the account. And encapsulation of the logic inside of the methods in bank account also means that users don't have to worry about the implementation details when interacting with a bank account object. For example, the user doesn't have to worry about the logic involved in withdrawing money. They can just call account.withdraw and then pass the amount that they want to withdraw. And the implementation details are hidden and encapsulated in the class. Okay, so they're all here. We don't have to repeat this logic, or any users of a bank account don't have to worry about the sort of complex details within withdrawing money from the account. Okay, and if the user tries to do something silly like deposit a negative amount, the program will throw an error and the user will be notified. So encapsulation of logic within methods in the bank account class allows users to interact with a bank account object without needing to know or understand the internal implementation details of how withdrawals, deposits, or other operations are carried out. So users of the bank account class can interact with bank accounts using a very simple, intuitive API or intuitive methods like withdraw or deposit, without needing to understand the complex logic behind these operations. So encapsulation abstracts away the complexity of the implementation details, allowing users to focus on the higher level functionality provided by the bank account class. Users only need to know about the public interface of the bank account class, in other words, its public methods or properties, to use it effectively, while the internal implementation details remain hidden. So in summary, encapsulation allows for clear separation between the public interface and the internal implementation details of a class, providing users with a simplified and intuitive way to interact with objects while hiding the complexity of how those interactions are handled internally. The aim of abstraction is to reduce complexity by hiding unnecessary details. So, for example, when you press a button on a TV remote, you don't have to worry about or interact directly with the internal circuit board within the remote. Those details, those complex details, are abstracted away. So let's go through an example of abstractions. So let's create an email service class. Whose job is to basically send emails. So to send an email, we have to first connect to the email server, then we have to authenticate, then we send the email, and then we disconnect. So let's create a few methods for sending an email. So we'll first create a method called connect, and this is going to be a protected method, and I'll explain why shortly. So let's just print connecting to email server, and we don't have to actually connect to an email server. We're just going to print connecting to email server. This is just for demonstration purposes. Then we can create a method called authenticate, and again we can just print. So let's just print authenticating, and finally we need a method for sending an email. So let's create a method called send email, and this needs to be a public method because users of this email service class are only really interested in sending emails. They're not too interested in connecting to the email server or authenticating. Those are implementation details, so details that are kind of specific to this class, but you know, outside of the class, no one really cares about those complex details. So we can create a public method called send email. And what this is going to do is it's first going to connect to the email server. So it can call, first of all, self.connect. Then we can call self.authenticate. And then we can send the email. So let's just print sending email. And then we need to disconnect from the email server. So let's create a method called disconnect. And this can also be a protected method because it only needs to be used within the class. Other classes or other parts of the program are not concerned about this. It's an implementation detail for this class. And we can say disconnecting from email server. And let's now call that method inside of our send email method. Okay, so let's actually put this public method at, actually we'll leave it here. So we connect, and let's see what's going on here. What did we do wrong? There we go. Okay, so first we connect, authenticate, send the email, and then disconnect. Okay, that's all good. So the user of this class can now send emails without any knowledge of the internal implementation details involved in sending an email. So all of these details have been abstracted away, and life is much simpler for users of this email service class. So for example, if we create a new email service object, and we now say email dot. So let's look at the methods available on this email service object. So we can see that we have some underscored methods. So as a Python developer, I know that I should not be touching these methods. I know that they are kind of to be used internally within the class, but outside of the class, I don't need to worry about them. So I can see here, I can look down, and I see a public method here, so no underscore, that says send email. So I know as a user of this class that I can just call this send email method, and the email will be sent. I don't have to worry about how emails are sent. I can just call send email. So life is really, really simple. And without abstraction, the user would have more decisions to make, as they are exposed to more information and complexity than is necessary to perform a task. And the user would have to write more complex code. So let's just, for example, change these protected methods to public. So if we get rid of the underscore, okay, and let's just comment these out for now. So send email just sends the email, but before this send email method is sent, we would have to first connect to the server. Then we would need to authenticate, and then after sending the email, we would need to disconnect from the email server. And you can see life is much more complicated for any users of this class now, because we have to understand how emails are sent, call all these methods in the specific order, correct specific order, and we have to repeat this code every single time that we want to send an email. So this would be an awful solution, really, with no abstraction. Whereas if we abstract all of those details away, all of those implementation details related to sending an email, then life is nice and simple for any users of this class. Okay, so if the methods are protected by being prefixed with an underscore, it's going to communicate to the Python developer that these methods are for internal use within the class and don't need to be touched with it to use the class as intended. And importantly, by using encapsulation, if any of these protected methods are changed, for example, they take another parameter, for example, let's say if we authenticate, we need to pass, say, I don't know, a username and password, for example. Currently we don't, but let's just say we did at some point in the future. Then only this email service class has to change. We just need to pass these values into the authenticate method here. Okay. Whereas if without abstraction, if we had to actually call this authenticate method outside of the class, then all of the users of this class would have to change. Okay, so it could potentially, we'd have to make a lot of changes in our code, and it would be very easy to introduce bugs. So by using abstraction, we can change the implementation details of email service without it affecting other classes or other parts of our application. So it may be difficult to see the differences between encapsulation and abstraction, as encapsulation is often used to support abstraction by hiding implementation details from users. So let's just have a look at the differences between the two. So encapsulation focuses on bundling data or attributes and methods that operate on that data into a single unit called the class, and it restricts access to the internal implementation details. So this is achieved by defining attributes and methods as private or protected and exposing only a control interface, e.g., in other words, the public methods. For example, by marking connect, authenticate, and disconnect as protected, hides their details from the user of the email class. Whereas abstraction, on the other hand, focuses on hiding complexity by providing a simplified high-level interface to interact with. So just by providing this simple send email method, we are effectively concealing the underlying implementation of sending an email. So it allows users to focus on what an object does rather than how it does it. So for example, the send email method, as we mentioned, abstracts away those multiple internal steps required to send an email, providing a nice and simple interface for the user. So just to clarify even further, encapsulation emphasizes bundling and restricting access, while abstraction focuses more on simplifying usage by hiding unnecessary details. So, and it's also important to note that encapsulation is a mechanism that enables abstraction, but they are still distinct concepts. Inheritance is a fundamental concept in object-oriented programming,